All right, so we are going to look at express each equation in general form. So what we have here is we have equations that are indeed not in any form that we recognize yet, actually in point slope form, but we need to write these in general form. One thing I just want to remind you of is, for example, if I have a constant times a binomial, you need to distribute that multiplication to both terms of the binomial. So I'm going to express in general form. Let me take a look at this first one. Y minus 2 is equal to 3x minus 1. So I notice that there is going to be 3 is being multiplied to a binomial. So the first thing that maybe I should consider, not necessarily all the time, but I'm going to distribute that multiplication to both terms. So 3 times x is 3x. 3 times negative 1 is negative 3. So there we have it. I have y minus 2 is equal to 3x minus 3. So what I'm going to choose to do now is I'm going to bring everything on the left-hand side over to the right-hand side. Keep in mind that the general form is ax plus by plus c is equal to 0. That's general form. That's what we're talking about here. So what I notice is that my coefficient of a is 3, so it's positive. That's what I like. So I'm going to just move everything to the left-hand side to the right. So it's 3x minus y plus 2 minus 3. So in other words, I wanted to get rid of y, so I subtracted y to the other side. I wanted to get rid of negative 2 to the left-hand side, so I added 2 to both sides. And it makes it disappear, because they are inverses. Now I have 0 is equal to 3. I'm just going to clean this up and see where we are here. I'm going to collect these like terms. There we have it. So is this in general form? Oh, I made a mistake there. It should be 3x. Is this in general form? Yeah, absolutely. So I'm just going to write, I don't know why I like my 0 to be on the right-hand side, but maybe it's going to help me out in the future. But it's in general form. It has the form ax plus by plus c is equal to 0. Check. Is a, b, and c integers? Absolutely, they're integers. Is a positive? Yes, a is positive. Check. So that's in general form. Now let's move on over here. All right, good times. Again, I'm going to take a look. And what I notice is that I have a constant negative 4, and it is being multiplied to a binomial. So what I should see on the left-hand side is y plus 3 is equal to, now on the right-hand side, I need to multiply negative 4 by x. So negative 4 times x is minus 4x. Negative 4 times negative 2 is going to be positive 8. And just like that, so now if you notice, it's almost in standard form. My coefficients are all integers, which is fabulous, but my a is negative. So what I'm going to do is I'm going to add 4x to both sides, and I'm going to subtract 8 to both sides. And the reason why I'm going to do that is because if I move 4x to the other side, it becomes positive. There we have it. So I have 4x plus y minus 5 is equal to 0. That's really good. A, b, and c are integers. A is positive. One side is equal to 0. Bob's your uncle. Call it done. Now, let's go over here. Now, this is an interesting case. I think it's interesting. Perhaps you don't. So do you notice that we have an integer value here? But what's really brilliant about equations, we do not have an integer value. This is rational. It's a fraction, 3/4. So what is really great about equations is we can employ this idea that what we do to one side, we can do to the other side, and that holds the equality of the statement. Now, here's me just thinking aloud. Is there any number that you would multiply to 3/4 so that the product or the answer is an integer? And you would say, yes, of course, 4. Right? So that your numerator and denominator would have a factor of 4 and they would cancel each other out. So what I'm going to do here, and I'm going to be very deliberate and careful here. Y minus 2 is equal to 3/4 times x plus 8. What am I going to do? I'm going to multiply both sides by 4. So I multiply this side by 4, and I multiply this side by 4. Notice on the right-hand side, on the left-hand side, it is a constant times a binomial. So my thought process is when I'm multiplying this, I have to multiply 4 to both things. However, in multiplication, this is just an aside, did you know that A times B times C, I don't know, we could pick real numbers. 3 times 2 times 7 is the same as 7 times 2 times 3 is the same as 3 times 7 times 2. It doesn't matter the order of operations, the order of multiplication here. So let me just get back over here. That has nothing to do with it. I'm going to choose to multiply 4 times y times negative 2. Because this is a monomial into a binomial, you have to multiply both terms. The reason why I set it up, the right-hand side like this, is wouldn't it be nice if I could multiply the right-hand side by a constant 4? And look what happens when I multiply it by 4. That's 4 over 1. And what I get is the factor of 4's cancel each other out. So really, this simplifies to 3 times x plus 8. Sometimes people believe that I needed to multiply 4 to this and 4 to this, but in fact, I took care of the multiplication of 4 times 3 over 4. I chose to evaluate this first. Why? Because it was the easiest to do. The only thing that changes this from a grade 6 question is the fraction, but a fraction is just a number. Anyways, there's my step. So I'm going to say multiply 4 times 3 over 4. And that is going to be 3. There we are. So next step I'm going to do is I'm going to distribute my multiplication. So 3 times x is 3x. 3 times positive 8 is positive 24. And the left-hand side stays the same. And to write this down, I would write it down as multiply right-hand side. And really, I'm just multiplying 3 times x plus 8. And then I'm just going to reorganize. Now, you guys are probably getting the hang of this. Look at this. My a value is positive. I'm dealing with everything that is an integer, which is pretty fabulous. So why don't I move this and this over to the other side? So now maybe I'm going to take a more casual language. Moving 4y to the other side becomes minus 4y. Moving negative 2 over to the other side becomes positive 2. And my resulting equation in standard form is 0 is equal to 3 minus 4y plus 26. All right, let's move on. One more. Ugh. Gross. I wonder if there's a number that I can dream up of where negative 7 over 3 times some number will yield an integer. And really, no big secret, is going to be the denominator, which is 3. So I'm going to choose to multiply both sides by 3. So I end up with 3y plus 18 is equal to, so that's 3. So I have a factor of 3 canceling out on both top and bottom. So maybe all I'm left with is negative 7 times x plus 3. So I'm just going to maybe annotate in the step above, I multiplied both sides by 3. In the bottom, I just simply multiplied 3 and 7 over 3. And it reduced to, negative 7 over 3, and then reduced to negative 7. So I'm just going to maybe try to clean things up. A lot of times in math, I don't know what I'm doing next, but it's just to simplify and see what comes. So I'm going to take a look at my green step. I'm multiplying a constant into a binomial, so you need to multiply that to both terms. So that turns into minus 7x. Negative 7 times x is negative 7x. Negative 7 times 3 is minus 21. Hooray, hooray. So now what I notice here, if I'm cleaning this up, remember that my coefficients for a, b, and c have to be integers. Also, the coefficient in front of the x, the a, has to be positive. What I've just underlined in pink is that it's negative. So right now, maybe I'm going to move negative 7x to the other side by changing it to positive. But in actuality, I'm adding 7x to both sides. So that would be gone now. And I'm just going to clean this up. I should have given myself way more real estate here. So 7x, I added 7x to both sides. And then I need to take care of this minus 21, so I'm going to add 21 to both sides. And then I have 3y plus 18. On the right-hand side, I have 0. And how would I annotate this? I would just say add 7x and 21 to both sides. Do you see how it cancels each other out in algebra? Please tell me to slow down if you're not totally getting this. We can discuss it in class, but it's hard when you're just watching this video. Anyways, I'm going to reorganize this, see what's going on. So I noticed that I'm going to collect like terms. I have 2 constants there. So 7x plus, I'm going to put my y's next, plus 3y. And then 21 plus 18, that is 39, is equal to 0. All right. Good luck. Sort of fun with algebra. All the best.